Hello everyone, my name is Sudheer Kumar, working as an assistant professor of mathematics, MLR Institute of Technology. Today I am going to discuss about double integrals by region, where the limits of x and y are not given. Evaluate double integral of x square plus y square dx dy. This region is given in the positive quadrant for which x plus y less than or equal to 1. So first let us draw the line. This is the line x plus y equal to 1 and this is x axis origin, this is y axis. X plus y less than or equal to means the region should be towards origin, right? But this is only in the positive quadrant, so the region of integration is completely in the first quadrant. By identifying the region of integration, we have to find the limits of x and y. So in this region of integration, that is in the first quadrant, to find the limits of x and y, first let us fix x limit as constant. Let us fix x limit as constant and write y limits in terms of x. So whenever the limits are not given, either you fix x limit as constant or fix y limit as constant. Now let us take x limit as constant and write y in terms of x. To write down y in terms of x, what we have to do? Draw a vertical strip or a vertical line in the region of integration. This lower end of this line, wherever it touches x axis, that is lower limit. Upper end of the line touches this line x plus y equal to 1, so that is upper limit. So identify the or label the values, corner points of the region of integration. Of course this is 0 comma 1, this is 1 comma 0 and this is origin 0 comma 0. So from O to the point A, the x coordinate changing from 0 to 1, we can clearly see that x varies from 0 to 1. So we are fixing x limit as constant. And what are the y limits? Lower end of this vertical strip touches x axis, that is y equal to 0, to another end of the touches the curve y is equal to 1 minus x. So this x is equal to 0 to 1, y is equal to 0 to 1 minus x. The function is x square plus y square dy. First we integrate with respect to y, then with respect to x, because x limits are constant. So x is equal to 0 to 1. So integration of x square dy is x square into y plus y square dy integration is y cube by 3 and the limits are 0 to 1 minus x. So if you integrate this, x square into, in place of y write down the upper limits, plus 1 minus y whole cube, 1 minus x whole cube by 3, complete integration dx, x equal to 0 to 1. So this can be written as integration of x square dx minus integration of x cube dx plus integration of 1 minus x whole cube by 3 dx, x is 0 to 1, x is 0 to 1, x is 0 to 1. So this is x cube by 3 minus x power 4 by 4 plus 1 minus x whole power 4 by 12. Here the sign is minus sign. Limits are 0 to 1. So if you substitute the upper limit x equal to 1, we get 1 by 3 minus 1 by 4 minus lower limit. So upper limit minus lower limit. In place of x, if you write down 0, this will be 1 by 12. So if you take out the LCM, 4 minus 3 plus 1. So this is 1 by 6. So this is how we evaluate the double integral when the limits are not given. Instead, the region of integration is given. Now let us see one more problem. Evaluate double integral of xy dx dy taken over the positive quadrant of this ellipse. Positive quadrant means, first let us draw the ellipse. So the region of integration is in the first quadrant of this ellipse. So this is x axis, this is y axis, this is origin 0, 0. Again, same as the previous one. To identify the limits for x and y, either you fix x limit as constant or y limits as constant. Let us fix x limit as constant here. Let us fix x limit as constant. So on x axis at any point you can see y coordinate is 0. So if y is 0, we can write this x square by a square equal to 1. So x square equal to a square. So we get x is equal to plus or minus a. So this is the point minus a comma 0. And this is the point plus a comma 0. We are not taking the region complete ellipse, only the first quadrant. So the first quadrant is exchanging from 0 to a. Otherwise, if we consider the region to be in the total ellipse, then we can take minus a to a. So here x varies from 0 to a. So we are fixing x limit as constant. Now to write y limits in terms of x, the curve equation given as x square by a square plus y square by b square equal to 1. So y square by b square equal to 1 minus x square by a square. So a square minus x square by a square. So that implies y square equal to, if we cross multiply, we get b square by a square into a square minus x square, right? So y is equal to plus or minus b by a under root of a square minus x square. Again, from this point is negative of y, this is positive of y. We are not considering the total ellipse, rather we are considering only first quadrant. So I want only this part. So y varies from, but the region is in positive quadrant. The region is in positive quadrant or first quadrant. Therefore, y varies from 0 to plus b by a under root of a square minus x square. So we have identified the limits for x and y, right? Therefore, double integral of xy dx dy, this can be written as x is equal to 0 to a, y is equal to 0 to b by a under root of a square minus x square, and the function is xy. So one limit is variable limit, one limit is constant. So we have to first integrate with respect to y, then with respect to x, right? So what is integration of xy dy? X into y square by 2. So this is equal to x equal to 0 to a, x equal to 0 to a. What is integration of this? Xy dy, x into y square by 2, and y limits are 0 to plus b by a under root of a square minus x square dx, right? So this can be written as x is equal to 0 to a, x by 2 into, in place of y write down upper limit, b by a whole square into a square minus x square dx, right? So this 1 by 2 and b square by a square, b square by a square, take it outside, integral 0 to a, x into a square minus x square dx. This is for complete thing. So b square by 2 a square into integration of a square into x dx minus x into x into x square is x cube. So we have to dx. So this is equal to b square by 2 a square. What is integration of a square into x? A square into x square by 2 minus integration of x cube is x power 4 by 4, and the limits are 0 to a. Limits are 0 to a. So b square by 2 a square into, in place of x substitute upper limit a. So a square into a square is a power 4 by 2 minus a power 4 by 4. So this is equal to b square by 2 a square into, if you take out the LCM for this, this will be a power 4 by 4. 1 a square and a square cancel, b square a square divided by 8. So this is the answer, right? Now let us evaluate one more integral. Double integrals, let us see in polar coordinates. To evaluate this double integral in polar coordinates, this is of the form double integration of f of r comma theta dr d theta over the region where the limits of r and theta are not given. In this case, the procedure is, first sketch the region of integration. Is it in the first quadrant or first second quadrants or what? We have to identify the region of integration, and after identifying the region of integration, label the bounding curves, corner values you label it, then identify the limits for r in terms of theta. R limit should be in terms of theta and theta limits as constant limits. Once we identify limits for r and theta, it is easy to evaluate the double integral. Let us evaluate one problem. Evaluate double integration of r cube dr d theta over the area included between the circle r equal to 2 sin theta and r equal to 4 sin theta. So first let us draw the curves. Small circle, this is r is equal to 2 sin theta, and big circle, this is r equal to 4 sin theta. So we have to, that area is included between these two circles. So this is the area included between the circles. So first we have to identify the region of integration. This is the completely the region of integration. So this is the area we have to find between these two circles. So once we, this is origin, of course this is theta equal to 0, this is theta equal to pi by 2, this is theta equal to pi, and so on, right? So between these two circle means I want this area. So r equal to 2 sin theta is this point and r equal to 4 sin theta is this point, right? So we have to write r limits in terms of theta. So here r varies from, by seeing the diagram we can clearly see that r varies from r equal to 2 sin theta to r is equal to 4 sin theta. That is clearly given in the question between these two circles. And we want complete circle area. So there is no positive quadrant or first two quadrants. Clearly theta varies from 0 to 2 pi. Now we got both limits for r and theta. Let us evaluate this. R equal to 2 sin theta to r equal to 4 sin theta. Next, theta is equal to 0 to 2 pi. The function is r cube dr d theta. So first theta equal to 0 to 2 pi. What is integration of r cube dr? Integration of r cube dr, then d theta. This is r equal to 2 sin theta to r equal to 4 sin theta. So this becomes theta equal to 0 to 2 pi. What is integration of r cube into r? R power 4 by 4 into d theta. Here theta limits are 2 sin theta to 4 sin theta, right? So theta equal to 0 to 2 pi. R, the limits for r and 4 sin theta, upper limit r equal to 4 sin theta whole power 4 minus 2 sin theta whole power 4 total divided by 4. So this 1 by 4 take it outside. Let us write in next page. So this is equal to 1 by 4 into theta 0 to 2 pi, 4 power 4 sin power 4 theta. So 4 power 4 sin power 4 theta integration minus 2 power 4 sin power 4 theta, 2 power 4 sin power 4 theta d theta, and the theta limits are 0 to 2 pi. So 1 by 4 into 0 to 2 pi. What is 4 power 4? 16 16s, 256. 256 sin power 4 theta minus 2 power 4 is 16 sin power 4 theta d theta. So this can be written as integration of 0 to 2 pi. 256 minus 16 is 240 into sin power 4 theta d theta. So 4 ones 4 60s. So this can be written as 60 into integral 0 to 2 pi sin power 4 theta d theta. I can write this as 2 times of integral 0 to pi by 2. We can see here the limits are 0 to 2 pi. So 0 to 2 pi I can write it as 2 times of 0 to pi by 2 sin power 4 theta d theta, because I know the formula integration of 0 to pi by 2 sin power m theta d theta, where m is even or odd. We have separate formula. So for that I am writing this integral as 2 times of 0 to pi by 2 sine power 4 theta. So this is 60 into 2, this is 120 into integral 0 to pi by 2 sine power 4 theta d theta. So 120 into, if you integrate this, there is separate formula. Here we can see that the power of m, that is m equal to 4, is even. So we can write this as 3 by 4 into 1 by 2 into pi by 2. So this is 4 30s, 2 15s, 2 2s. So this is 45 by 2 into pi. This is how we evaluate the double integral in polar coordinates. Thank you.